Welcome to this explainer. Today, we are diving straight into question 15 from the November 2023 Edexcel Higher Tier Paper 2. We're going to completely decode it, walk through the exact workings, and list every single possible accepted answer directly from the official mark scheme.
Here's our quick roadmap for today. Unpacking question 15, Part A on completing the table, Part B for drawing the bars, Part C on estimating the median, and we'll wrap up with the alternative valid answers.
First up, unpacking question 15, the scenario. So picture this. We've got a scenario involving 43 students running a race. This data is being represented simultaneously by a grouped frequency table and a histogram, with time intervals ranging specifically from 10 to 26 seconds. The whole trick here is showing fluency and moving back and forth between the numerical table and the visual histogram.
Now let's look at Part A, completing the table. Part A comes right out and asks us to find the missing frequency for that very first time interval. That's the spot where time t is greater than 10 but less than or equal to 12.
To figure this out, we just calculate the area of that first bar. We take the class width, which is 2, and multiply it by the frequency density of 1.5. That gives us a frequency of exactly 3.
And when you look at the exact wording in the examiner's mark scheme, you actually earn a B1 unconditional accuracy mark simply for placing the number 3 right there in the first row. Seriously? No complex workings required for this specific mark at all. Just drop the correct number in the correct box and you're good to go.
All right, moving right along to Part B, drawing the bars.
So here, the script flips. You have to use the given frequency table to physically draw the 2 missing bars for the final 2 time intervals. To pull this off, we need to calculate the frequency density by dividing the frequency by the class width. For the 19 to 21 interval, that's a frequency of 9, divided by a width of 2, giving us a density of 4.5. Then for the 21 to 26 interval, it's a frequency of 7, divided by a width of 5, landing us at a density of 1.4.
Checking the official mark scheme, the examiners will hand you a total B2 mark for drawing both of these bars correctly at heights of 4.5 and 1.4. But they gracefully offer a B1 partial credit mark if you only manage to get one of those 2 bars drawn to the correct height. Pretty fair, right?
Which brings us to the big one, Part C, estimating the median.
This part asks us directly to work out an estimate for the median of the times taken by those 43 students to run the race. This is where you really have to translate the visual, geometric area of the histogram into precise algebraic interpolation.
Earning full credit here is all about following a sequential logic process, broken down into 3 totally distinct phases. First, you calculate the area of at least 2 bars to prove you actually understand the histogram scale. Second, you mathematically lock down the median's position within those 43 students. And finally, third, you use interpolation to pinpoint the exact estimated time.
Let's break down the alternative valid answers.
To snag that very first M1 method mark, the scheme actually lists several valid area calculations depending on which bars you choose to check. For instance, you could calculate the first bar as a width of 2 times a height of 2, giving 4, or maybe the second bar as a width of 4 times a height of 2 to get 8. The official mark scheme explicitly accepts these calculations along with 4 times 4, 2 times 6.5, or 4 times 0.5 as completely valid evidence of your mathematical process.
What's super reassuring here is that the official instructions specifically tell examiners to condone one error in reading frequency density values or measurements when awarding this first M1 mark. Meaning, if your eye just slips by one tiny grid square, you aren't completely derailed from earning your method marks.
Moving to the second M1 method mark, we need to find the actual median position. And get this, you can either use the formula of 43 plus 1 divided by 2 to get the 22nd position, or simply take 43 divided by 2 to get the 21.5th position. Both of those conventions are fully accepted.
Now for that crucial interpolation calculation to lock in that second method mark. If you aimed for the 22nd value, you'd realize you need 10 more runners to reach the median group. You divide that 10 by the 16 total runners in that specific interval and multiply by the group's time width of 4 seconds. That gives you 2.5 seconds to add to your baseline. But if you use the 21.5th value instead, you would just use 9.5 instead of 10 in your numerator, giving you 2.375.
Bringing the whole thing together, the final A1 accuracy mark is awarded if your final answer matches either 18.5 or 18.375 exactly. These numbers represent the final estimated median time in seconds, completing our real-world race scenario perfectly.
The mark scheme perfectly validates both approaches, but it leaves us with a genuinely fascinating mathematical reality. When we estimate from grouped data, the absolute correct answer depends entirely on the statistical convention you choose right at the beginning. So, considering both are valid, which method of finding the median feels more precise to you?